Hello, in this video we are going to take a look at a procedure to develop an interconnect test in ontap, and so to do so we select the development screen, and from the development screen what we'll do is we'll browse to a project folder that has the BSDL files and netlist that we need. So we have selected the project folder, and in that folder we see there is a CAD netlist. This is a Xilinx style netlist, and some BSDL files. The BSDL files, boundary scan description language files, describe the JTAG implementation on vendors' devices. The default name is interconnect for the first test that we're going to develop. We will click open to open the project, and that takes us to the scan page. Now there are a number of pages within the development screen. Each page has a specific task to do. For example, on the scan page we will define the JTAG chains in the application, and on this page we have a list of BSDL files, a list of all of the devices on the board, and they're ordered by pin count, higher pin counts first, because generally the boundary scan parts, JTAG parts, have higher pin counts than the others. So we need to assign BSDL files to the JTAG parts on this board. So the first one is this FPGA, and I know that goes on U1, so we do that. There's a CPLD, and that is U3. We'll match that up. A Xilinx System ACE, which goes to U2. Notice the JTAG files are moved to the top as we do this, which is where we're going to define the chain. Okay, so the BSDL files have been matched up, but the JTAG chain order, the order from test data in to test data out, has not been correctly defined yet, and ontap's giving us a tip here with red tint saying these are not in the TDO to TDI order. Now we could just click this button and it would order them for us, but just to show that it can be done manually, we will put U4 at the top where it should be. That's the test data input part. You order them like so, and the FPGA is at TDO, the TDO end of the chain. That defines the A chain. We can have any number of chains which we can label A, B, C, D, and so forth. And for each chain you would need a channel on a USB, and you can have multiple USB controllers. So we will click OK. The chain is defined. The next page wants us to define the types of nets that we have, and we can do that by simply selecting a net. That's a ground net. There are some power nets, and the ground net, power nets, and a voltage reference net. The other thing that should be done on this page is assign models to non-JTAG parts that need to be transparent during automatic test generation. So here we have a list of users' non-JTAG parts, and over here we have a list of transparency models. For example, if you were to select one, you would see the pin mapping from input to output and any control pins in the level that they need to be. For example, not 25, and pin 24 should be positive. So that's one of the transparency models. If we look down through our list of parts, we see there are some resistor packs, 8-pin resistor packs, and those should be assigned to a model we call ohm by 4, And in this, it's a simple pin 1 maps to 8, 8 to 1, 2 to 7, 3 to 6, 5 to 4. So we're going to put that in here. And there is a mechanism that can be found in help to create your own models and add them to the list. So are there any more of these? There are some more of these owned by 8s or owned by 4. And we'll just use the same model, make that assignment. And there may be others, but for now we'll get on with it and go to the next page. You can always come back during debug and redo that. Jumpers page is used to account for connections on the board that are not in the net list. So if you had, say, a connection between U3 and this pin and U4 and this pin, you could just click these two pins and the jumper would be shown up in this jumpers list. And then when you develop the test solution, the jumper would be incorporated in that test solution. We don't have any jumpers on this demo. So we'll go, we want to go to the guards page. On guards, there may be certain pins that we need to hold statically while the test is running. They might be pins that prevent contention, enable power, prevent resets, whatever it might be. And as an example, we'll set a pin, and oftentimes it's helpful to look at the net names because sometimes they're a clue as to the type of pin it is. For example, here, flash output enable will be during the test, especially during the shorts test where there are a lot of pins switching. We don't want the outputs enabled on flash, memory devices, and other types of things. So we'll select the pin, and when we do, we have a whole list of guards that we can set. In this instance, we want drive output high, so we'll set that output high. And I'm sure there are others that we need to set, but that's an example, and we will simply go on. The cluster page is where you would set up a test to test memory devices, larger devices that aren't handled by the transparency models. Flash programming procedures could be done here, and we're going to devote a whole tutorial to this page. So for now, and because it's an interconnect test, we're simply going to go on. Testability, if we had any warnings, they would be shown here, and at the moment we don't. On the test gen page, we have a test plan, and that lists all of the tests that are going to be run and the options that are going to be set in the tests. In addition, there are a list of available instructions, for example, external files, SVF files, and other types of files. And those instructions or files can be dragged in at various locations into the test plan. We don't have anything that we want to drag in at the moment, but just taking a look at the test plan, if we had a test reset pin, which we don't in this application, we could set it here. We're going to do a state reset because we want to get that's the first thing we're going to do because we want to get the JTAG chain into a known state. Test logic reset. That test access port means that's what we're going to test this, and when we test the port, we're going to do, for example, on chain A, that's the only chain we have, we're going to do an instruction capture test, which includes an instruction register length test. We're going to do a bypass register test, an ID code test, and we could do a boundary register length test, and that will come back and measure the boundary register length and report it. This is an interconnect test, so we have a list of our chain. We can select any of the devices, the device opcodes, and the opcodes from its BSDL file will be shown here. So if we wanted to change the opcode setting, we could do that. We will Put that back at X test. There are some options. This cable is attached, so when we run the test, it will create an adapter file for the USB controller based on this information. You can always go into the controller's menu and change this. Change the JTAG chain that's assigned to a particular channel or the TCK rate. There are a number of interconnect test options. For example, do you want to do a sample preload instruction? You can put in delays, retest on failures, number of things. You can set some options to do 1149.6 AC testing by selecting the opcodes that you want to run, and when you do that, that will automatically be assigned to the opcodes in your JTAG chain. We don't have any .6 AC devices on in this application, so we pretty much are now ready to go, and we can simply create test. And the test generation algorithms will run when we do this. Okay, the test is completed, and when it completes, a number of reports and files are available. For example, we just created an interconnect test, and this is the SVF serial vector format file. It has a breakout of all the tests that we're doing, the JTAG chain, a recap of what's in the BSDL files, plus a hex formatted SVF file. These are all the scans or test vectors in the tests. And these test vectors are designed to detect opens, shorts, tap failures, and come back and report the failure to you. In addition, there are a number of reports that are test coverage reports that are available. The other thing that is available is a ProScan page where you can take a look at the test, and there's a tutorial dedicated to ProScan, but it's going to list all of your boundary scan pins and show you exactly what the tests are, drive and sense values throughout the test. And then you have a number of options and commands. If you need to debug, for example, add guards and that type of thing, then you can do so right on this screen. So that wraps it up for the test development procedure for an interconnect test. Thanks for watching.